Okay, so the recording has started and we were discussing functions. So have you guys any questions related to functions, especially what we have studied so far, like how to declare a function, how to define a function, okay, what's the difference between declaration and definition, and how should we use those functions? How can we call a function? Okay. And the second thing is how do we pass information to a function? Okay, through its arguments. And how can we return a value from a function which we can receive whenever we call a function. Okay, these were some of the things that we have discussed. And if you have any questions related to these, you can ask them now before we start any thing new. We'll continue with functions this week also. Previous lecture की videos YouTube पे डाल दें. Okay, I am very sorry. I'll do it today. Okay, definitely. What is function overloading? We will study it either this week or next. Function overloading is something that we will study. How can we use string arguments? So again, for the moment, don't worry about strings. By the way, it would and just a small comment that it would be used just like any normal type. Okay, you can use string just like you would use a normal type in passing arguments to a function or returning a value. But we have not studied strings yet, so we will come to it later when we study strings in a couple of weeks perhaps. एक फंक्शन में दो ऑपरेशंस हो रहे हो तो रिटर्न क्या लिखेंगे? Okay, by two operations you mean you are doing two different calculations and you have two different results. Is this what you mean? Okay, so
yes sir, yes.
Okay, so there is a general rule about using functions that usually a function should do one thing. Okay, please remember this, that usually we define functions in such a way that a function usually does only one thing. Okay, and it returns a result related to that. If you have functions, one function that is doing two different things, then maybe there is some problem in your design and you should basically split that function into two different functions and do those two different things separately, each within its separate function. Okay, it's a general principle that we have when defining functions. A function should do only one thing. Otherwise, you will mess things up. Is it clear? So it's one of the good practices that we recommend in computer science that a function should usually do only one thing. Any other question? Is there any lab tomorrow? Your lab instructor will tell you about this, but normally, yes, there should be a lab tomorrow. Okay, is there any other question? No questions? Okay, so we'll continue where we have had left off last week. If you remember, in the last class before the midterm, we had discussed how a program, when it is loaded into memory, how does it look like? Okay. Every program is assigned a portion of memory, RAM, and that portion of RAM would basically contain different kinds of information about a program. So who can tell me what were different portions that we can find for every program in memory? Remember, there were different segments which contain different information about the program when the program is loaded in memory. Heap, very good. What else? Stack, good. What else? Heap, stack, what else? Okay. Instructions, heap, stack, data, very good. Okay. So there's a section in RAM for instructions which we call the code segment or the text segment. Okay. Let me share this image with you guys, so I think you will have a better idea what I'm talking about. Where is this sharing icon? Share. So here is something that I googled just now, and you guys can see that every program is assigned some space in RAM. Okay, so let's say here I have a program running P1, and this is the RAM space that it is assigned. Okay. When you run another program, let's say hello world.exe, again it would be assigned a RAM space when it is loaded in RAM, and its RAM space would also look like this. Okay, when you run Microsoft Word, again when it is loaded in RAM, it would be assigned some space in RAM, and that space would look the same, or it would be divided into same kind of segments for Microsoft Word. Okay, so every program when it runs, it is loaded in memory, it is assigned space in memory, RAM, and the organization of that RAM segment, RAM space for every program has the same structure. Okay, whatever that program is. So there is a segment or portion of RAM for every program which would contain its code. Okay, here at the very bottom in this image, you can see this uh, segment called text segment. Okay. So the text segment contains the program code, its instructions. Okay, as you guys said, it's sometimes also called the code segment. Second, if you move up, these two segments combined, they are the data segments. Data segment basically contains the program data that was inside the executable file. Okay, here you see at the right of this image, you can see these arrows which say that read from program file by exec. Okay, the program file here is the executable file. So your operating system would load your executable file into RAM, and it would read the instructions and the or the code from the executable file, and also it would read this data segment or data from the executable file. Okay. So the data segment is divided into two kind of data segment is divided into two sections. One is called initialized data and the second is called uninitialized data. Okay, so the text segment contains the code instructions. What does the data segment contain? What kind of data it is? Could you repeat? It can't get anything. Can't you hear my voice? So can you guys hear my voice? But I can't understand you. What do you mean by you can't understand me? These were things that were discussed before the meet, and I am repeating it. So even if you don't understand it, like I'm repeating from zero, so there should be some information that you should find the useful. The process, yes, I am telling you that I am repeating it from zero. Whenever the program is loaded in RAM, it is assigned a portion of RAM. Okay, so that portion of RAM would contain the program code in a special section in a portion, which is called the text segment or the code segment, where the operating system will put the program code that it read from the executable file. Secondly, that portion of RAM would also contain a section for the program data that the operating system read from the executable files. Okay. So my question was that for those who were present in the class before the meet, what does the data segment contain? The executable data? No, that is not the executable data, but data is not executable, by the way. Only instructions are executable. Okay, so we separate our executable file into two different things. In our executable file, there are instructions which are executable or which are executed. And then there's the data. So the instructions basically operate on that data. Okay. So data is not executable. Instructions are executable and instructions use data during. So executable data is not a correct term. Global variables and local variables. No, local variables are not contained inside the data section. You are correct about the global variables, that this data section contains global variables. Okay, so this last answer is correct, Hamza Siddiqui, that data section contains the global variables. Okay. So I hope you all know what is meant by global variables. Any variable that is declared outside of every function, which is not inside any function, it's called global variable. Okay, so this data segment would contain global variables, and it would contain constant variables, any constants that you have defined, and any literals that you have used in your program. They will be contained inside the data segment. Some of this data, global data, would be initialized data, and it would be in this initialized data section, this set from the, and some of this data would be uninitialized, so it would be in the uninitialized data section, the third from the bottom. Okay, so these two combined will make up the data section for every program in RAM. Okay, is it clear what I said so far? Every program, when it is loaded in RAM, is assigned a portion in RAM. Okay, and that portion is composed of multiple sections. One section will be used to keep the program code. We call it either a text segment or a code segment. A second portion is used to keep or store programs global variables, constants, and literals. Okay. So this section is called data segment. It is further divided into two segments: in initialized data segment and uninitialized data segment. Okay, so these are two segments that I have discussed so far. For every program, we will have these two segments in RAM. I'm coming to the next two segments, but before that, I want to make sure that you guys are following what I'm saying. Is it clear? I was fluctuating. I'm not sure is it the case for everybody or only a few of you. Okay. So let me plug in the network cable if you guys are saying that this Wi-Fi is not working correctly. Okay, so now I am on the LAN cable network. So how is the voice quality now? Because on my end, it is saying that everything is fine. Yes, before I repeat, would you please answer whether the voice quality now is better or not? Okay, so I hope it's better now. What I was saying is that every program, when you run it, it is first loaded in RAM. And when it is loaded in RAM, every program is assigned a portion of RAM. And the structure of that portion that is assigned to every program is the same. So every program will have in RAM a code segment which will contain the program's code or its instructions. Secondly, every program will have a data section in RAM which will contain all the global variables, constants, and literals that you have used in that program. Okay, so this data segment, you can see it in the figure. The bottommost segment is text segment where you'll have the instruction of the program, and the two segments above the text segment collectively make the data segment. Half of it will be used for initialized data, all the variables that you have initialized in your program, the global variables, and half of it would be used for uninitialized data, all the global variables that you have not initialized in your program. Okay, so this will be the data segment for every program. Is it clear so far? It would be nice if you guys answer. Is it clear what I've said so far that every program in RAM will have a section reserved for code, a section reserved for its global data, constant literals. Okay, so these are two sections, and then every program will have two more sections also. Okay, so again, the two more sections also you can see them in the figure. For every program, we will have a section called heap. Okay, right now we will not discuss what heap contains. We'll discuss it at the end of the course. So we'll skip heap, but the other section, the last section that every program will have is called a stack. Okay, so stack is the segment in memory that concerns us right now. Okay. The objects that are created for program means primitive local variables. Where did you read this statement, or where did you what's the question that you were asking? So all these reactions that are like angry or whatever, please behave yourselves in this class. Let me be the judge. Okay, so Uzair Rahman, as I said, we are skipping heap right now. Okay, so any discussion related to heap, we will have it at the end of the course. Right now, we are not going into it. Okay, because right now it's the stack section that interests us. So every program will have a portion of memory which is called stack. And what does the stack contains? For those who are present in the, very good. Okay, so stack will contain local variables for our programs. And what do we mean by local variables? What are local variables? What is a local variable? Defined inside functions. Very good. Any variable that is defined inside a function is a local variable. Okay. Yeah, we'll come to scope also. Scope is something that we need to discuss, but for the moment, let's start with the definition of the local variable. That any variable that is defined inside a function is a local variable, and any variable that is not inside any function, it means it's outside of every function, that's called a global variable. Okay, so that's the definition, difference in definition of global and local variables. Now we'll further dig a little. What do we mean when we say that a variable is defined inside a function, it's a local variable, and if it's defined outside every function, it's global variable? What does it mean in practice, okay, in the working of the program? So the key thing to remember about local variables is that local variables are created whenever a function is called. Okay, whenever you call a function, all its local variables are created from zero. And when you execute that function, those local variables are used. And when that function is finished, when the execution of that function is finished, all these local variables are destroyed. Okay. So every time, let's say we had a function called f1. It has two local variables x and y. So whenever I call this function f1, these local variables x and y will be created from zero. And during the execution of those that function, those x and y variables will be used. And when the execution of that function finishes and the program returns execution flow, it returns back to the caller function, those local variables will be destroyed. And when I call f1 again a second time in my program anywhere, those x, y variables will be created again. Okay, they'll be created again, and then again they will be used during execution of the function. And when the function finishes execution, those local variables will be destroyed again. Okay? And when I call f1 a third time, all its local variable will be created a third time. And when the f1 finishes execution a third time, all its local variable will be destroyed again a third time. Okay, and so on. As long as you keep calling these functions, all the local variables of the function will be created every time the function is called, and whenever the function execution finishes, the local variables will be destroyed. Okay. Global variables, on the other hand, are created when the program starts running. When the program is loaded in RAM, global variables are created, and the global variables are not destroyed until the execution of the whole program is finished. Is it clear? That's the difference between the working of global variables and local variables. Global variables are created when the program starts execution, and they remain, or they are not destroyed until the execution of the whole program is finished. Local variables, on the other hand, are inside a function, and they are created whenever a function is called. Okay, they are created new. Okay, every time the function is called, they are created, they are used, and when the function call finishes, the execution of the function finishes, local variables are destroyed. Okay, so local variables, during the execution of program, local variables are created as many times as you call the function, and every time the function finishes, these local variables are destroyed. Okay? That's the difference between the working of local and global variables. So let's call it the lifetime of these variables. Okay, lifetime means when a variable is created, as long as the variable lives and when that variable is destroyed. Okay, let's give this definition as the lifetime of a variable. So the lifetime of a global variable is the whole program, the execution of the whole program. It's created when the program starts, and it remains and is only destroyed at the end of the execution of the program. So the lifetime of the global variable is the whole program. The lifetime of local variable is only a function call. As long as that function is being executed, that variable will live, and when the function execution finishes, the uh, local variable will be destroyed. Okay, so local variable lifetime is it's created when the function is called, it is used, it is alive during the execution of the function, and when the function execution finishes, local variable is destroyed. Is it clear? The difference between the lifetime of local variables compared to global variables. And we already discussed that global variables are stored on in the data section. Sorry, the global variables are stored in the data section, and the local variables are stored on stack. Okay, so we'll basically now see how does stack work. Okay, so there were some questions. Use inside program function also kind of global variables. For the moment, let's not treat functions as variables. Okay, function is code and variable is used to store data. Okay, functions store code as well as data. So we'll distinguish between functions and variables for the moment. Are argument global variables? Yes, as Rafi said, all the arguments of function are also local variables. Okay, very good. Okay, I stream std find num 20 main cout num func num 10. Destroy का क्या मतलब है वेरिएबल के लिए जगह अलॉट होती? Yes, so yeah, this is a good question. What do we mean by destroy? Okay. So whenever a variable is created, space is allocated for that variable inside RAM. Okay. And when I say that a variable is destroyed, it means that space is taken back from the program and it can be used for something else now. Okay, so that space that was allocated for that variable does not exist now because that variable has been destroyed. Okay, so we can allocate the same space to some other variable now. Okay, so that's what we mean by variable creation and variable destruction. Variable creation, space is allocated for that variable inside RAM, and variable destruction, that space is no longer associated with that variable and it could be used for some other purpose. Achha, what's this code that you are pasting, Usman? Usman Tahir, would you please tell us by unmuting yourself what do we mean by this code?
yes sir. ये जो मैंने num का ग्लोबल वेरिएबल बनाया है, इसकी मैंने वैल्यू फंक्शन में चेंज किया है, और जब मैंने मेन में इसको सी आउट कराया तो चेंज ही यानी वो शो हुआ है.
हाँ, so
तो ये क्या सीन है सर?
main cout num, this num. Okay, so let's discuss. Okay, let me copy paste. Okay, I'll come to this code, but first जब फंक्शन बनाते हैं तो वो int main करके ऊपर होता है, उसका आर्गुमेंट ग्लोबल होगा या लोकल, क्योंकि वो यूज तो int main के अंदर हो रहा है. Okay, I think this will also be discussed in my example. Variable होता है change होने के लिए. Okay, I think this is not a question, this is just a comment. So, okay, we'll start with this code that Usman Tahir has pasted and we'll see how it works in practice. So I'll unshare this screen and share another screen with you guys. Okay. So here, okay, it's basically same screen, but I closed the tab. So here I hope you guys can see this screen called where I am typing code in a browser. Okay, so this is a website. I'll give you the link, but right now you guys can see this code, I hope. Can you guys see the screen with int main, etc.? Okay, good. So let's say I type a function. Let me type a function here. We'll do our usual stuff. So let's say we'll use the same function add that we used last time. And I'll declare it here and I'll define it after main. Okay? I'll declare the function here and I'll define it after main. Okay. So this is our function add, and what we will do, we will basically, let's say we call this function inside our main multiple times. Add 5. Um, 7, 8. Add. Okay, whatever, 2 plus 2 to keep them simple. And what I will do is I will basically int num is equal to 0. And we'll basically assign all these things to num. Okay. So I have written this very small, simple code. Does everybody know what this code is doing? I mean, only answer if you don't know. Those people who don't know what this code is doing. So there's no answer. So I hope everybody knows what this code is doing. I don't know. Who is this? Mohammad Sarmad Shahzad. Alishba Javed. You guys have not practiced the functions, I think. So this function basically, this code defines a function add, which is taking 2 arguments, x, y. Okay. So it is adding these 2 arguments and storing the result in z, and then returning the result, which will be the sum of the 2 arguments. Okay. And then in main, we are basically calling this function 3 times. Okay. So the first time I call it, I pass it arguments 5 and 34. And second time I pass it 7 and 8. And third time I pass it 2 and 2. Okay. So what it will do is calling this function would basically execute the code of the function, passing it the arguments, the first argument in x and the second argument in y. And then it will execute the code of this function. The code of this function is a couple of lines. It basically adds the values received in these two arguments and stores the result in Z, and it returns the value Z. Is it any clearer now for you two? Sarmad Shahzad and Emil Jamil. Okay. Sarmad Shahzad also, I hope it's clearer. So we will basically proceed to run and execute this code. So here I have this visualize execution. The good thing here is that it will help us visualize some things. This site is sometimes slow, but okay. So here you see we are in this function main. Let me increase the font, zoom in a little. Yeah. So I hope it is visible clearly now. That the thing we have done is that we have compiled this program and we have basically started the execution, and you see this red arrow. Right now the execution of the program is blocked on this line 8. Okay, so this line 8, the program has started execution, which means the code section has been created, the data section has been created, and the main function has started execution, and we are on the first line of this inside main function int num equal to 0. So num, as you know, I mean you can guess, is a local variable because it is defined inside a main function. Okay, so all local variables are stored in RAM on stack. Every program has a stack. Okay, so you see here in the stack column we have this function main, and inside we have space allocated for num. The variable num has been created, which means space has been allocated for this variable on the stack, and so far there is no value. Okay, we know its type, but the question mark saying that it doesn't contain any value, which means it has garbage value. That is because line number 8, which is assigning value to num, has not yet been executed. Okay, so if I execute line number 8, where is it? This next. Line number 9 has 8 has been executed, and we are stopped at line number 9. Now you see the variable num, which had space allocated on stack, has been assigned the value 0. Okay, now this has been executed. So now we are at line number 9. At line number 9, if I say step next, so you see line number 9, we were calling this function add. Okay? You know what add means, calling a function means. Calling a function means the execution flow jumps from line number 9 to line number 16. Okay? It will jump to the body of the function and start executing the function. Okay? So now you see x and y did not exist before line number 9 was executed, before add function was called. Okay, x and y did not exist in RAM. Okay, x and y are local variables, and they are created only when a function is called. Okay, so now add function is called, so its arguments, you see this, there was a question that arguments are local variables or not. So yes, arguments are local variables, and they are created whenever the function is called. X and y are arguments, they are local variables, they did not exist before the function was called. So as soon as we call this function, local variables are created, x and y, you see, and x and y, so far they have not received these values. The values that we passed to arguments were 5 and 34. So I move one step more. Next, now we are inside the add function. So you see x and y have been assigned values 5 and 34 that were passed here. Okay, local variables were created when the function was called, and these values were passed to the arguments x and y. The first value was passed to the first argument, 5 was passed to x, and 34, the second argument value, was passed to this second argument y. Okay, so x receives 5, y receives 34,
and z also, which was a local variable, is now created. Okay, but the value has not been assigned because line number 18 has not yet been executed. Okay, so these local variables, they are created on stack. Can we initialize x and y line 5? No, as Usman said, line number 5 is just declaration. Declaration is just to tell the compiler what the function will look like. Okay, the execution happens in the body of the function, which is inside the definition. Okay, so you see local variables are created when the function was called. Now if I proceed further, next, x plus y value has been stored in z. Okay, you see num is still 0. Okay, the value of num has not been changed. So but these three local values have been created and values has been assigned, and in the end I am saying return z. Okay, so return z. Next we have reached the end of the function, and now you see this, look at the stack which has num and xy, and z also has been delivered. Let's assume that z is also there. So if I do next, the execution of this function has finished, and if you go on the stack, all those local variables have been destroyed. Okay, and the return value 5 plus 34, 39 has been stored in num. Okay, so the function was executed, the result was then assigned to num. Okay, and now we are calling add again. We are calling add again, and you see there is no x and y right now here, z also. If I do next, again we are inside the function, x, y have been created again. Okay, and then next, z is also created, z has stored the value x plus y 15, and then when we return from z function, they have been destroyed again. Okay, num is still there because main function has not finished execution, so main variables will live until end of the function. So again on line number 11 I call add again. We are here again. Next, x, y, z have been created, assign value to z, and return destroyed again. Okay, so next, and now even num has been destroyed and the program is finished. Okay, okay, I'll send you the link. Previous num की values continue नहीं हुई. Oh no, num is only one variable. So every time we assign to num, the old value is overwritten by the new value. Okay, just like you assign to any other variable. If you assign to a variable at 3 different places, only the last value will remain. The previous values are overwritten by new values. Okay, so this is how local variables work. There's one more thing I would like to illustrate, that is why do we call a stack a stack? Okay, what does this name mean, stack? Stack is something like putting things on top of each other. Okay, and just like a stack of plates. Okay, you have like different plates stacked on top of each other, and the stack basically is called stack because there is a certain behavior associated with the stack, which is called last in first out. Okay, the last thing that you put on stack will be taken out the first. Just like a stack of plates, the last plate that you have put on the stack should be taken out first, otherwise it's no longer a stack, it will not work. Just like you have, let's say you have a stack of 1000 plates. Okay, you can't pull plate number 10 directly. Okay, because plate number 10 is under 990 plates. So first you will have to take out those 990 plates, and then you will be able to access or take out plate number 10. Okay, so the last thing that goes in stack first, the 1000th plate was put on a stack last, so it will be taken out first. Okay, similarly, if you look at this stack in function, let's say I call it add here, and then in add basically I call subtract. Let me just change this code a little again, and we'll see why a stack is called a stack. Okay. I will just declare and define at the same place. Int sub int or actually sub is not a good example, but let's go with this same thing. I'll declare it here. And here we add another function. Sum and difference. And let's call it A and B. It doesn't matter, but just to avoid confusion. Out. But it would be like okay, so I'll put it at different lines because it would make things clearer. Otherwise, you guys will be confused. And here we basically call it let's say we want 9 and 7. So this is my program. I have two functions. In okay, last if we put cout at the end, okay, we'll see this now. I have three functions in this program. Add, you've already seen it. Sum is sub is basically subtraction, so it will return the result of x minus y, and then display sum div. It is not return anything, so I would convert it to return type to void. It is basically taking two numbers as arguments, and then it will display the sum as well as difference. So here we're calling display sum diff with 9 and 7 as arguments. So let's visualize its execution. Sum was not declared in the scope. Sum, it's called add, sorry. Oops. Good. But it's not diff, it's sub. Hooray, it's good. So you see, whatever is in our file, it doesn't matter. The execution will always start at main. Okay, so it will start at main, and here you see we are at line number 16, and there are no local variables. So on stack, you see only main and there are no variables in main. So now we call this function display sumdiff. So I call next, and we are basically at the start of calling sumdiff. Basically took us to the body of display sumdiff, and we are at the start of this function sumdiff. So you see, in stack we are putting things on top of other things. First there was main and its variables, and now on top of main we have this data for display sumdiff. So they are the arguments a and b. So here I do next, and we are at line 11, and line 11 we are calling add. Okay. So I do next, and calling add means we have jumped to the body of add. Okay. So in add we have these variables x and y, and if I do next we are at z. Okay, so local variables have been created x, y, z for add. Now you see the order of things in step. First it was main, and on top of main we put data for display sumdiff ab, and on top of display sumdiff we put data for add. Okay, x, y, z. You see, so the thing is, this portion of memory works like a stack. Like whatever was put on last will be taken out first. Okay, so in last we have put the data for add. So data for add would be destroyed first. So you see, if I do next and return, as soon as add is finished, data for add has been destroyed. Okay, so out of the three things, main, display sumdiff, and add was put on the last on the stack, and it is destroyed first. That's why this area of memory, since it's behave in last in first out fashion, it's called a stack. Now we are in display sumdiff, which is not finished, and we are at line number 12. At line number 12 we are calling sub. Okay, so I do next, so we have basically jumped to the body of sub. Okay. We will execute sub. The on stack space has been created for the function sub with its arguments z, x, y, z. Again, they have been created when the function was called. We see that z is equal to x minus y, and you see next, and the execution finished, and this portion of stack has been destroyed. All the local variables of sub has been destroyed, and now we are at the end of display sumdiff. Okay, so if I do next, you see, we are back in main. The execution flow is back in main, and the space for sumdiff and its variable has also been destroyed. Okay, so here in this stack, whenever you call a function, local data for that function will be created. Within that function, if you call another function, then on top of that, local variable, local data for the latest function will be created, and within that latest function, if you call a third function, then on top of that, local variable for third function will be created. Okay, so this stack builds on top of each other with local data, function within a function, and whenever each function finishes, its portion of stack will be destroyed. Okay, so always the last called function will be finished first. Okay, so the local data that was put on the stack last will be destroyed first. Okay, similarly, as you continue execution, all the called function would finish execution ultimately, and their stack portions will be destroyed. Local data will be destroyed one after the another in reverse order of calling. Okay, because the function that was called last, its data will be destroyed first. Okay, and the function that was called first, like main was called first, its data will be destroyed at the last. Similarly, display sumdiff was called before add, so display sumdiff data was destroyed after add's data was destroyed. Okay, so this portion of memory, it behaves in last in first out manner. That's why we call it stack. Okay, and the stack is used to store local data for functions. Okay, is there any question? So this is a very useful website, especially for visualizing small things. It's called Python Tutor, and you can always access it at this link. You can type Python Tutor in Google and then select the C++ option. It supports many languages. So here's the link for the C++ editor. Okay. So there are some things that do not work here. For example, cin will not work here. Okay, but there are many things that work and you can visualize them. So any question about local data, how arguments of a function work, when are they created, when are they destroyed? Any questions so far? Local variables, global variables, how does the stack work? Hello, no questions? Okay, it seems strange, but if everything is clear to everybody, okay, yeah, there is a question. Can we have functions inside the arguments of other functions? Basically, arguments of a function should be values, okay? Those values can come from different sources. You can pass it a literal, as I was doing now. You can pass it as a variable. That variable will be evaluated and it would be, how would you say? It would basically the value returned that is produced at the end of the evaluation of that variable would be used as an argument. And if you use a function call, then before that argument is assigned the value, that function will be called, and the result of that function will be used as a value that is passed to these the argument of that function. Okay, so let me give you a quick example. Here, let's say instead of this, I call add. And the first argument I give add 2, 3, and the second argument I give again add 4, 4. Okay. So I'm calling add. Add takes 2 arguments, and in place of these 2 arguments, I'm calling add again, okay, with the constant arguments, literal argument this time. Okay. So what will happen is when this function add will be called, let's say I write it on different lines so it becomes clear to you guys. So when the function add on line number 17 is called, it will try to evaluate its 2 arguments to pass the values to x and y. So the first argument it will see that it's a function add. So to evaluate this value, it will call this add on line number 18. Okay. So it will add 2 and 3 and produce a result 5. So this line number 18, the argument value would be passed 5. And then it will try to evaluate the second argument of this line number add on line number 17. So this second argument is also a function called to add. So now this to evaluate the value for this second argument, add on line number 19 will be called by passing it the values 4 and 4, and the result 8 will be evaluated and it will be used here as second argument. The first argument will receive the value 5 and the second argument will receive the value 8. Okay, so just to give you guys a quick example, I'll delete all this other stuff. This is so okay, this is good. One line we can. Okay, So here I am and I say next. Okay, so right now we are on main and we are calling this add on line number 9. So I say next. So here add on line number 9 has been called and we are trying to evaluate the values for x and y. Okay? So the call to the value of x will again be evaluated by this call, line number 10, okay, by calling add. Okay, let's see whether it evaluates 9 first or x first or y first. Okay, so it is first evaluating the value for y. Okay, line number 11. So you see this add has been called and it's being passed the values 4, 4. Okay. So 4, 4 and the result will be produced 8 and so result is 8. And if I do next, it again goes here. The value of for y has been evaluated and it has been evaluated to 8. Okay. So now I do next and it calls add again. So this time it's evaluating the value for x, this line number 10. So we go next. You see it's between pass 2 and 3 and next z and the result is okay 5. We'll see. And now x and y have been evaluated. Okay, line number 10 and 11 have been evaluated. So it will go inside the add call in line number 9. So if I do next, you see it's a line number add call on line number 9. And if I do next, you see x has received 5 and y have received 8. Okay, which we calculated here. Line number 10 gave us the value for x and line number 11 gave us the value for y. So the argument values are evaluated in the reverse order. First y and then x. Okay, now that we have 5 and 8, x and y, we do next and the value is 13 and then we can return z and tada, main is finished. Okay. So I hope that makes things clear. Let me go through the questions. Can you give an example of a global variables? Okay, we'll do it next time. Should we leave? Just a minute. Can arrays be passed as arguments? Yes, very good questions. Any type can be passed as arguments. We'll see how arrays are passed in the next few classes. Please send a copy of codes. Okay. Formal and actual arguments में क्या difference है? Formal and actual arguments. I don't know what do you mean by these things. I have no idea. Can you send me the link where you found this thing? Screen is stuck. Okay, I hope it was working for some. Why 2 and 3 is x and 4 and 4 is y? I have read this in book. Okay, give me a screenshot of the book. Okay, so I'll see what does it mean. Why 2 and 3 is x and 4 and 4 is y? No, not 2 and 3 is x. Add is called first with arguments 2 and 3. 2 is passed to x and 3 is passed to y. And add is also called another time with both arguments equal to 4, 4, 4. So x also receive the value 4 and y also receive the 4. Okay. Why not 2 is x and 3 is y? Yes, 2 is x and 2x receives the value 2 and 3 receives the value y when that add is called. Okay. Eight plus 5 कैसे हुआ? Add is first call with values 2 and 3. The result is 5, and then add is called again with values 4 and 4. There the result is 8. Okay, so the third time add is called the main add function on line number 9. It basically gives the value x receives the value 5 and y receives the value 8. Okay, and they both came from the first two calls of x. The key difference between actual parameters. Can you guys send me the screenshot via email instead of pasting here? That way I would know the page number and can go look it up exactly in the book. Why this program is executing line number 11 rather than line number 10? Yes, the function arguments have to be evaluated. Okay, so apparently in C++ they are evaluated in the reverse order. First, the last argument is evaluated, then the second last argument, then the third last argument, then and so on until we evaluate the first argument at the last. Okay, so that's why line number 11 is executed first, because y is the second argument of the main. It is evaluated first. Screenshots via emails, please. No, this has nothing to do pass by reference. We'll study pass by reference soon. Any other question? Okay, so if you don't have any question, then I'll stop the recording here. You guys go ahead, read the book, try playing with functions, try writing different kind of functions and calling them inside one another, and try to visualize the execution using this website or any other that you find, and try to see how local data works with function, how stack works with function. Okay, so this distinction between local data and global data is important. Okay, so thank you very much. Those that they want who want to leave can leave, and mark your attendance by writing your name and reg number here. Okay? So thank you very much, and I'll stop the recording now. Stop.